Okay, so first thing is you may want to get out a highlighter or two. It may help you out. Next, they are giving us a function called f of x. What type of function is this? Linear, exponential, or quadratic? Elsie, do you know? It is a quadratic. Hey, folks, remember, quadratics, somebody's talking while I'm talking. Folks, remember, quadratics, those are the ones that were like the rocket problems. So you can see they go up and come down like the rocket problems. Did you have a question, Eli? Yeah, like the rocket problems. Quadratics are like the rocket problems. Okay, and also, y'all, if you didn't know, when you open up your notebook, we had the graphs separated, linear, exponential, quadratic. And we had pictures of all three. So you need to be able to recognize those. Okay? All right, next question. This was from yesterday. It says, where is f of x greater than 0? And I told you this notation was going to be tricky. But in yesterday's notes, remember, this is where the function is positive. That means positive. In other words, this is where the y values are positive. And again, this is in your notes from yesterday. And remember, we talked about that is above the x-axis. So this is where f of x is greater than 0, above the x-axis. Okay. This is where, and I don't want to shade the whole graph, this is where f of x is less than 0. That's where your y values are negative, and we took notes on that yesterday. So when it says where are the y values positive, we should be up here. Okay, so I'm going to, let's see, Lyric, what'd you get for number 2? Let's see if you got this right. Didn't do it?
I did it.
Okay. Well, don't be scared. What'd you get? Okay, no. Anybody got? No, it's okay. It's okay. Because anybody think they got it right? What you think, Aldo? Bentley, what you think? Y'all, let's see. Okay, now, y'all, I like that y'all are marking it, but I need for you to look. Y'all check it out. From here to here, y'all, that's where the curve is above the x-axis, from there to there. Well, how do I say that? Well, in between -3 and 1. So that answers C. Okay, next, something totally different, y'all. Where is it decreasing? Folks, you need to understand something. Where the function is positive or negative and where it's decreasing, those are not the same characteristics at all. Okay, in the last class, I had a student, and maybe a lot of y'all are thinking this. I had a student that said, okay, I thought where the function is negative would be decreasing. Y'all, these aren't even talking about the same two characteristics at all. Okay, decreasing is where you're going downhill on the curve. Okay, where the function is negative is where the values of y are negative. These are not any, they are not connected to each other, that question and that question. So where is the graph decreasing? Well, remember, we ride in the car from the left, always. So when I hit this curve, am I going up or down? So y'all, it's increasing here, and then all of a sudden right here, it changes and then does what? Then it decreases. So decreasing is this part right here. And how do we say that? How do we identify it? Well, the way we identify it is with the x value where it changes. That's -1. And then it is everything bigger than -1 because it's on this side. So if you wanted to write this, you could write -1 here. And then over here, you could write x is greater than -1, and over here, x is less than -1, and see, x is less than -1 is the interval where it's increasing. When x is greater than -1, that's the interval where it's decreasing. So the correct answer is x is greater than -1. Anybody get that?
We had it, but then we changed it to...
Oh, okay. All right. All right, hopefully we know what a vertex is. That is the very top or the very bottom of the curve of a quadratic. And y'all, linear functions don't have a vertex. Linear functions don't turn around. Exponential functions don't have a vertex. Okay, vertex is where it changes from increasing to decreasing or decreasing to increasing. So what is that ordered pair? It's the ordered pair -1, 4. So your vertex is the ordered pair -1, 4. Now, the reason why I asked that question is because I wanted to extend that and ask this question. What is the maximum value of the function? Maddie B, you know that? Madeline B? The maximum value of the function. I'll give you a hint. It's one of the numbers above it, right above it. Right in problem number 4. In other words, it's one of these. It's a 4, that's right. Okay, y'all check it out, y'all. This is what I talked about yesterday that I wanted to make sure y'all understood. Y'all, when they ask for the maximum value and the minimum, you should not be answering the x value. Y is how high and how low, y'all, the y values. So when it says maximum, you're using that guy right there. You're always using the y value. So the answer here is 4. How many people had that? Nice. Okay. And then notice, y'all, I'm trying to cover everything we've done. Now they're asking about end behavior. And if you notice, this is what we did in Delta Math. Okay? Okay, so on both sides, tell me where this curve is going. Where's y going over here? Is y getting bigger or smaller?
Smaller.
Where's y going over here? They're both getting smaller. By the way, quadratic, they have to both be getting smaller or both be getting larger because of the curve, because of the way, the shape of it. Okay? So they're both getting smaller. So which goes with that? Well, y'all, it's this one. Look at how it's written. On the right side of the graph, it's going to negative infinity. On the left side of the graph, it's going to negative infinity. That's the correct answer. Did anybody have that? Nice. Okay? And the hardest part that I'm going to try to explain better, the domain and range. Okay, domain. What x values are contained on this graph? I'm going to explain it different than I did yesterday. If you have an imaginary sweeper that's sweeping across these x values, notice how my arm is sweeping across these x values. Anywhere there's a graph, those are x values. So y'all, if you notice, the first thing I hit is an arrow. Well, y'all, what that means is that graph was going on before I got to this point. So all of these values are contained on the graph. I'm sweeping. Do you notice how I'm touching all these values? I'm touching this curve, touching this curve, touching this curve. At the end, what do I run into? An arrow again. What that means is this curve is going to keep going. It's going to keep going down, and it's going to keep going this way. So the x values are going to include everything here, all real numbers. That's your domain. The y values are different. Y'all, y values, you can use your sweeper down here. Okay, well, the first thing is when you get to this, you run into arrows, which tells us the graph is going on all the way down, all the negative y values. But y'all, look what happens when I get to right there. There is no more graph. There is no graph above the y value of 4. There's no graph above the y value of 4. So y'all, all your y values are going to be found 4 and smaller. So how do we say that? Well, that's y is less than or equal to 4. So the correct answer was, who knows? Anybody? D. Okay, and C is where I tried to trick you and made the 4 an x value. Okay, but remember the y values is 4 and less for the y values. Okay, and y'all, I know domain and range is hard, so that's why I'm just going to try to keep bringing it up for you. Okay. Okay, I need for you guys to get out, if you got glue sticks, get them out. If you got a highlighter, get them out. Let's open up our notebooks. And if you want to, go on back to page 1, and that way I can help you figure out where you're going. Because I know we're still struggle just a smidge. Okay, so we're going to the part where it says 111 across the page. 111 across the page. Get out maybe a glue stick. If you got a glue stick, we need it. Definitely may want to grab a highlighter or two in case you want to use the highlighters. No. Ace, were you here to get one of these? Yeah, okay. You'll see a lot of what's going to be in those videos. Everybody got their notebooks? Y'all make sure you're making room with your table partners so that everybody can get their notebooks. All 3 sections opened up. Don't forget, at any point, if your notebook is incomplete, you got videos where we're doing them, just saying. Okay. All right, so, is everybody where it says 111 all the way across? Okay. Okay. Okay, so now, we're going to fold in to where you see 2, 2, 2 all the way across. And y'all, yeah, it's maybe trial and error. If you fold it the wrong way, you're going to see that. Okay, all you do is pick it up and fold it the other way. You want to see 2, 2, 2 across the top. 2, 2, and 2 across the top. 2, 2, and 2. So again, if you fold one and it didn't work, then just flip it the other way. Okay, does everybody have 2, 2, 2 across their... Okay. Okay, so you glued on page 2 and not on page 1. So you might just want to try to find you some... You see where you glued on page 2 there, and it really was page 1. So you can do glue here if you want. You can do that. Glue here, and then what you may want to do is find your other blank graph. No, it should be somewhere right here. Okay. Okay. All right, here we go. Now, y'all, this right here is going in what I call the dead space. In other words, now that you got it going 2, 2, 2 across, all I want you to do is pick up one of the pages, fold them over. I want you to glue, and you can fold it right back.
Wait, just one page?
Just one page. Glue, then fold it right back. We're going right back to 2, 2, 2. So I'm going to shh. Folks, listen to me. Listen. Doesn't matter which side. Okay? If you want to turn that side in glue, fine. If you want to turn this side in glue, fine. All you do is turn one side glue and flip it right back to 2, 2, 2. Okay? So flip one side over, glue, flip it right back to 2, 2, 2.
Right on the middle? Or
Right in the middle. We're not doing anything else on that paper. I just need a spot to put this in.
yes, ma'am.
Okay? So the first thing I need for you to realize is we're gluing this so that it acts as something for us to read and as a reminder. It's not just a glue to glue. So letting you know, look at what we're getting ready to do. We're getting ready to look at the slope for these graphs. Okay, keep in mind, slope tells you how steep the curve is. It tells you how steep the curve is. Also, with slope, if the slope turns out to be a positive number, we know that's where the graph is increasing. If the slope turns out to be a negative number, we know that's where the graph is decreasing. Okay, now here's where this gets harder for you all, because I know y'all know how to find the slope, but it gets harder when you're distinguishing between these types of graphs. Y'all, the linear functions, the slope is the same everywhere. And if you remember, we would do and stuff, and y'all would say, Miss Batchick, which 2 points do I pick? And I'm like, it doesn't matter. Y'all, that's because you were doing linear. Okay, now, hopefully you remember when we did average rate of change, y'all, quadratic and exponential, the slope is not the same everywhere. So now it's called average rate of change. And y'all, we've average rate of change. So see, we're going to have to know that phrase so that when we see it, we know, wait a minute, rate of change is the slope. Average rate of change is still the slope. They're just going to tell me where to find it at. So if you recall, there was 3 ways to write your x interval. So this is just a little cheat sheet for you. That's all this is. And when you get done gluing, open it back up to where you got page 2, 2, and 2. And this is where your slope stuff's going to go. Slope stuff's going here. Okay. If you have something that obviously won't bleed too bad, you can literally go ahead and under the linear, you can write slope, slope. Under the exponential and quadratic, though, the slope changes names. It's called average rate of change, if it will not bleed through. If you want to write it in a pen, you can write it in a pen. So average rate of change goes for all the rest. And if you just want to write average rate, I'm fine, but you need to know that when it says average rate of change, that's the slope. So that's what we're doing for the rest of the day. And I hate to tell you, but today's going to be pretty boring. I'm sorry. And I know some of you are like, well, Miss Batchick, every day is boring with you. I get it. But today's really going to be boring because we're literally going to put stuff in this notebook for the whole day. Okay? Yep. So we're finding the slope for these guys. Linear, exponential, and quadratic.
No, like where's slope is there something else? Like, what is that?
You don't know what slope is?
No, I know what that is. It's the thing beside the slope.
Oh, it's a colon.
Oh.
It's just a colon. I see what you're saying. Nah, I make bubbles out of my colons, sorry. Slope, average rate of change. If you want to just shorten that to average rate, average rate, average rate. It's fine. I'm just helping y'all get everything set up for yourself, okay? What you may want to do, are these what I want to do, and I don't really kind of know how to fix it, but you may even want to go so far as to just start you see what I'm saying? And write L, and write slope, write what I've got, and leave space for these graphs, and I can give you the graphs. How about that? So leave a space here, and then write that, and I'll give you the graphs. And if you need to know how your notebook is set up, you can watch the video. Yeah, they were in your notebook. I don't mind giving you, like I've got a copy or two, but they were in your notebook when I handed you your notebook. Just letting you know. And again, if you need to go back, Madeline, if you go back to those videos, we're literally setting up those notebooks. Okay. So, raise your hand if you can tell me how we find the slope when we have a graph. It's not doo-doo. You can make it doo-doo, but it's not doo-doo. How do we find the slope? Lyric. It's rise over run. So for every single one of these folks, it's rise over run. Okay? So if you want to write this one time or every time, that's up to you. But y'all, the way you find slope with a graph is rise over run. It is a fraction. Rise over run. It's a fraction. Rise over run. Okay? All right. So we are going to find the slope a couple of places on this line. The first thing I want you to do is I want you to put some ordered pairs. I want you to indicate some ordered pairs on here. So watch carefully. And y'all, this is a great ordered pair because the curve goes through the corner of the box. Let's mark this with your pencil or pen. Let's go ahead and do it, folks, so you don't get lost. Okay. Right here is a great ordered pair because it goes through the corner of the box. Need to be marking these, folks, or you're going to get lost. Okay? Right here is a great ordered pair because it goes through the corner of the box. Okay? So I am going to pick 2 points. I'm going to do a right triangle and rise and run. So I'm going to pick this one and this one. I'm going to draw me a right triangle and I'm going to rise and run. Okay? So I'm going to rise 1, 2, 3, 4, 5, 6. I'm putting that on the rise. And I'm running to the left. 1, 2. Why did I say left so loudly? Because it's in the negative direction. And y'all, that's not an ordered pair. Y'all, that's not an ordered pair. That's division. So y'all, we can simplify that. 6 divided by negative 2, this is a slope of negative 3. And y'all, I need you to watch carefully because I'm going to go ahead and let you know what's going to happen at the end. At the end, you guys are going to do this on a worksheet and hand it in today for a grade. So I'm just saying you need to be focused, not just writing down what I write down, okay? And this is old stuff. This should not be new right here. Okay, so now y'all, to prove this constant business, I'm going to find 2 other points or a different place on here, okay? So this time I'm going to rise and run here, okay? So I'm going to get me another color and I'm just going to draw the triangle underneath because it's okay to draw the triangle underneath because now I'm going to do this point and this point. So watch what happens. I'm going down 1, 2, 3 and to the right 1. Down 1, 2, 3 and to the right 1. So down 3, right 1. What does that equal? Look there. The slopes are the same. Okay, we're going to do one more point. One more set of points. Okay. All right. Let's do this guy. Let's mark him. Let's mark him. And this time, let's use this guy. Okay. So now, I love colors. So now I'm going to mark rise over run with this. Okay. And let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is down 9 and over 1, 2, 3. Okay, so down 9, right 3. What does that simplify to? -3. Y'all, with a linear model, the slope is the same everywhere. Okay, that's important. So this is what we're going to write at the bottom. Slope is constant. We need to know that word. Slope is constant. What does constant mean? The same everywhere. The same everywhere. And y'all, that is with a linear model. It's the same everywhere. Slope is constant. Okay? Okay, let's go over to our other linear model. I'm going to pick a couple of good points if y'all will locate them with me. Y'all, that's a good one because it's almost indicated. That's a good one because it's almost indicated. And let's find us another one. Let me see, hang on. Okay. We need to find where it goes through the very corner of the box. Okay, here's one. There's one right there. It's hard because the line's kind of thick. Okay, let's see if we can find one more. Let's see. Okay, here's one. Okay. All right, so those are some good points if you want to mark them. Okay, I'm going to pick 2. I'm just going to use these 2. And let's rise and run. Okay. So we're going to rise 1, 2, 3. And we're going to run 1, 2, 3, 4, 5, 6. So we're going to rise 3 and run 6. What does that reduce to? 1/2. Well, remember, it's bigger on the bottom, so it's not 2, it's 1/2. Because I know y'all see a 3 and a 6 and go, okay, it's 2. Well, it's actually 1/2. Okay, so now let's do 2 different spots. This time I am going to choose, let's choose this one and this one. Let's draw our right triangle. We rise 1 and run 2. We rise 1 and we run 2. Rise 1, run 2. Look what's happening. The slope is constant. Why? This is linear. The slope is constant. It's going to be the same. No matter what 2 points you pick, the slope is going to be the same. Remember, how steep the line is what the slope is about. So the slope, the line has the same steepness everywhere. As far as how slanted it is, it's the same slant everywhere. Okay? Are we good? We good? Okay. Okay. Y'all, the slope is not the same everywhere here. Okay, and one way to tell is if you pick 2 points, need everybody watching, y'all, if you pick 2 points and put a line, okay, see how slanted my board is? Okay, now I'm going to pick 2 other points and put the board. Do you see how my board's kind of flattening out? And then if I picked a point here and here, it's getting steeper. So y'all, the slope is not the same everywhere here. So that's why we changed the phrase from slope to average rate of change. From slope to average rate of change. Okay, because we're taking an average. All right? Okay. Let's see. How do we specify our intervals? We specify them 3 different styles. And they're right here. Here's the way to specify them. Okay? So the first thing I'm going to do is we're just going to write all the different intervals that we're going to find our slope for. So we are right here. Everybody locate this. Everybody locate this. Okay, I'm going to go ahead and write your 3 intervals. So we are going to find the slope for the interval that is between 0 and 1. And notice that's an x in the middle. That's less than signs 0 and 1. And y'all, I want you to leave yourself a space. The next interval, I'm going to write it in a different way. Notice the brackets. We're going to find the rate of change from 0 to 2. Do you notice the brackets? Does anybody have an idea why I would want to use brackets and not parentheses? What does it mean if this had a parenthesis? Do y'all know what that? It's an ordered pair right on the graph, right? Y'all, the reason for brackets is for you to understand this is not an ordered pair. These are X values, both of them. That's why brackets are used, because it's not an ordered pair. This is not an ordered pair. Okay, well, let's do one more interval, and I'm going to write it the third way where it might say something like this. From x equals 1 to x equals 2. Notice the 3 different ways they're expressing this. This is an inequality symbol. This has brackets, and this just literally says x equals 1 to x equals 2. Okay. Okay, while we've got, I'm sorry, what did you say?
You said okay, I was like, I'm not okay. Because, which one are you on? Like, I know you said it, but mine's like,
Right there.
mine are opposite.
Okay, then right there. So you know where you're at now, right? Okay, so put that there. Put that under it. Okay. For this one, let's go ahead and get these written. I'm trying to get it set up for you. So for this one, let's go ahead and write these 3 intervals. So on this side, we're going to do the interval from x equals -2 to x equals 0. I'm going to write another interval a different way, from x equals -2 to x equals -1. And then lastly, I'm going to write it a third different way. These are all finding x values right here. xx, xx, xx. We're going to find the average rate of change from -3 to -1. And again, notice I'm leaving spaces. We're just getting our notebook set up is all we're doing. And I'll be more than happy to wait a sec. It's not a problem.
I keep, I cannot see that.
That better? Are you filling
Use
it?
contacts.
Okay, are you filling this out?
Oh, I'm done.
Okay.
That was Bryce.
I know you need to be quiet because we're not going to talk about Bryson. We're not going to make jokes. You need to be quiet. Probably turning around will be helpful. Okay, so y'all, after the last class, I realized there's an issue with finding the ordered pair where x is 0, finding the ordered pair where x is 1, finding the ordered pair where x is 2. So y'all, I can help you guys out. We're going to do it a different way in this class. So check this out. The first thing we're going to do is we're just going to label some points on this graph. We're just going to label them. Okay? So, let's start with this one here. First of all, I want you to put a point there, but I want you guys to tell me, what is that ordered pair? What is the ordered pair that represents that point? And y'all, we should be able to say this. It is 1, 3. It's the ordered pair 1, 3. Okay. All right, let's do this one. Everybody put a dot. I want to know what that ordered pair is, and let's label it. What is that ordered pair? It is 0, 2. That ordered pair is 0, 2. Okay, and let's do one more right here. What is that ordered pair? 2, 5. Okay. So we're labeling the points on the graph. And now I think this is going to help you. I need to find the slope from where x is 0 and x is 1. So let's find that. Y'all, this point is where x is 0. Notice x is 0. It's this point. And then this point is where x is 1. Notice this point is where x is 1. So y'all, I'm going to find the slope from here to here. And I'm still rising and running. So I'm going to go ahead and get a highlighter and do that. Okay, so notice y'all, this is where x is 0, this is where x is 1, and notice it says where x is from 0 to 1. And by the way, y'all, this is old stuff. I think you guys have a foldable, a blue foldable on average rate of change. I'm just letting you know. So you could actually go pull that foldable. Okay, so rise, and y'all, you got to be careful with the rise and run here because every block is a half. So we're going to rise 1 and run 1. So check it out. I'm just going to write rise over run again to remind me what I'm doing. 1 over 1. So the slope over this particular interval is 1. Okay. Now we're going to go where x is 0, from x is 0 to x is 2. So y'all, where is x 0? Well, it's right there. Where is x equal to 2? It's right here. So x is 0 here, x is 2 here. We're going to rise and run from here to there. Okay? So I'm going to grab me another color. Okay, and I'll be honest with you, you can actually go under this thing, by the way, y'all. It's the same thing. I mean, you don't have to draw your boxes above the curve. You can draw them under it. Okay, so let's rise and run. Down, and remember, every block is a half, so you're skipping one. Down, 1, 2, 3, left, 1, 2. I'm going to do it again. Down, 1, 2, 3, left, 1, 2. Down, 3, left, 2. When I simplify that, what is my slope? 3 over 2. And y'all, 3 over 2 and 1 are not the same. This is actually 1.5. Notice the slopes are not the same. That's why we use the phrase average rate of change instead of slope. We are literally taking an average from here to there. Okay? All right. From where x is 1 to where x is 2. Okay? So let's go to our graph. Okay? Right here is where x is 1, so you can see that. Right here is where x is 2. So y'all, now we're going from here to there. So I'm going to draw my right triangle. We're going from here to there. I'm going to draw my right triangle. From here to here. So watch, I'm going to rise 1, 2, and run 1. I'm going to rise 1, 2, and run 1. I'm going to rise 2 and run 1. So, 2 things for you to notice. First off, your slopes are different everywhere. That's what happens with curves that are not linear. Next, do you see how this is increasing everywhere? Positive slope. positive slope, because everywhere on this line, when I pick two intervals, it's going to be increasing. Notice my slopes are positive. Okay? All right,
Is that a 2 above?
2 over 1.
Is it always going to be different slopes for quadratic and exponential?
That is it. That's what I'm trying to get y'all to understand. Hey y'all, that's why you've got 3 pages open, because I literally want you to look at this and go, wait a minute. The slope is the same when it's a line, but the slope is not the same when it's exponential. That's exactly right. And that's why we don't call it slope anymore. We call it average rate of change. Great question, Elsie, love it. Okay, now believe it or not, you guys are going to do these, but I'm going to help you. The first thing I want you to do is write your ordered pairs down. So I need to know this ordered pair. Go ahead and put your parenthesis with a comma. I want to know what that ordered pair is. I want to know what that ordered pair is. And I want to know what that ordered pair is. I want to know what those ordered pairs are. Okay? Want to know what the ordered pairs are. So this one right here. Bryson, what is the ordered pair here?
What happened?
Right here. What is the ordered pair here? I want the ordered pair.
That was 3 and then
Yeah, -3, and what did you say?
8.
-3, 8 is this ordered pair. Thank you very much. Okay? This ordered pair,
Me.
Austin,
-2, 4.
that is exactly right. -2, 4, that's exactly right. Okay? This ordered pair, Ace, -1, 2. And this one's always tricky for y'all. Although you want to do that one's always tricky. What's
0 and 1.
0, 1? The reason why it's tricky is because some of y'all don't know where to put the 0. But y'all, on the x-axis, it's a 0. Okay, so now, the reason why I located the order of pairs is because it's easy on y'all to figure out what 2 points are you doing. So y'all, for this one, we're doing from x equals -2 to x equals 0. So look at your x's. Do you see? X is -2 is this one. X is 0 is this one. So that's going to be your first one. And y'all, I'm not going to do these for you. I want y'all to try them first. Remember, the x-axis skips. The x-axis skips. No, they don't skip boxes. So you're in good shape. So y'all, want you to rise and run from -2 to 0. So here, rise and run. Tell me what y'all get for rise and run. Rise and run. What's my rise? 1, 2, 3. Javon, you don't count when you put your pencil down. So that may be what you're doing. You don't go 1, 2, 3. Do you see what I mean? You put your pen down and then count 1 block, 2 blocks, 3 blocks. Does that help a little?
Yeah.
Okay, so the rise is 3, up 3.
Isn't it up 3, over 3?
Okay, and then the run is actually, do you see the tick marks? It's actually over 2. Do you see that? And we're moving to the left. So what's that? That's -2.
I think that's what gives me, like, I count when I go over 2. So I'm supposed to, like, look at the line underneath it.
Yeah. Well, and these graphs are just kind of funny. See how wide it is? It kind of makes you want to, like, count. Yeah.
Yeah.
Okay. All right, so y'all, my slope here is -3/2. Okay, now I want y'all to find the slope here. So check it out. Where x is -2 and where x is -1. This is not an ordered pair, y'all. So where x is -2, that's here. And where x is -1, y'all, that's here. Look, there to there. So let's draw a right triangle. And we're going to rise and run. It's from here to here. Rise, run. So y'all tell me what you get. We're going to go up 2 and left 1. Up 2 and left 1. Rise, overrun. Okay, look what's going on here, y'all. Slopes aren't the same. But they're all negative, and look what this curve does. It goes down all the time. Okay, and let's do our last one.
Wait, I have a question.
Okay.
I'm confused. So, like, if you go up and then, like, you go over, like, I'm confused because you said, like, it's supposed to fall on that line. So, wouldn't it be -2? How do you get 1 out of it?
Okay. You talking about when I did this from here to here? If you look down, and again, do you see how wide these boxes are?
Yeah.
That's throwing you off a little. See, from here to here, look how wide that box is. But so when I'm here and I move to here, I'm only moving 1.
Okay.
And then when I move in the left direction, Elsie, that's negative.
Okay.
So I'm moving from here to there. I only moved 1 block. And since I moved to the left, that's negative.
Okay.
Does that help a little?
Yeah.
Okay. Okay, now let's do this last one, where x is -3 and x is -1. Okay, well, here's where x is -3, and here's where x is -1. Check that out. And y'all, for this one, so that it doesn't get confused with the rest, I'm going to go under. So here's where x is -1. Here's where x is -3. So now, there's the rise and run. Okay, so let's count. Down, 1, 2, 3, 4, 5, 6. And to the right, see, I'm having trouble. 1, 2. So I'll count again for you. Down, 1, 2, 3, 4, 5, 6. To the right, 1, 2. Down 6 over 2. And when I simplify that, what do I get? -3. Y'all look, different slopes, but they're all negative because the exponential graph decreased everywhere. Okay? Okay, now, you guys are going to do the quadratics, but I'm giving you the intervals, okay? Okay. So let's write down all the intervals. Eli, you need to be on that one. Everybody else, do you see where it opens up? Do you see it's opening up? Okay. I'm going to give you 3 intervals under the one that opens up. Here we go. And if you want to write slope equals rise over run to help you remember what you're doing. Okay, skip some space to give you room. The next interval is where x equals 1 to x equals 4. Skip some space. The next interval is where x equals 1, and this time we're going to x equals 3. Okay, and the one on the right over here is where the graph is turning down. I'm going to give you 3 intervals for that. So, bracket, -5, where x is -5, going to where x is -3. Skip some space, where x is -1 and goes to where x is 0. And then lastly, from x equals -1 to x equals 1. Okay, so I'll let y'all get that recorded. Let's get all that recorded. And then I'm going to help you find some points on your graph. Can you read everything, Lyric? Yeah, let me let these guys write. Oh, you would need to see, that one opens up, and that opens down. This side's where it opens up, this side's where it opens down. Okay, let's start labeling some ordered pairs. So I'm going to help you with some. Okay, here's an ordered pair that you're going to need to know. Here, here, here. It's going to help you to know that one, this one, and this one. See, y'all, you need to write what all those ordered pairs are. And if you can't find your x-axis, y'all, your x-axis is right there. That's your x-axis right there. Okay, here's your x-axis for this one. Okay, you're going to need this point, this one, this one, this one, this one. Thought there was another one. This one and this one. So y'all, you need to write some of those ordered pairs out. Okay, what's this ordered pair? What's that order pair? -2, 0, yep. That's the order pair -2, 0. Okay, what is this order pair? It's 1, -9. Okay, and what is this order pair? Almost. You switched it. It's 4, 0. The X part comes first. And then we're going to need one more. This one. What's that order pair? Well, it's on your graph, so you should be marking them on your graph.
Oh, 3, -5.
It's the order pair 3, -5. What's wrong?
All my pencils are messing up.
So y'all, by the way, notice, do you see X is -2? I need that order pair. Where X is 0. Oh, I didn't do the one where X is 0. Let's do that one. This one right here. That one right there is the order pair 0, -8. Okay, so y'all, you can go ahead now and find your slopes. Look, X is -2, X is 0. You're going from here to there. Rise and run. Need to venture out there and try to do it by yourself, y'all. Look, where X is -2 is there. Where X is 0 is here. You need to rise and run and write it down. Okay, X is 1 is right here to X is 4, which is right here. So from here to here, you're going to rise and run. So I want you guys to try to do it by yourself before, some of y'all are just kind of waiting on me to do it for you. I need you to try to step out there and do it by yourself. This is actually not new stuff. We did a whole foldable on it. It's just been a while. It's just been a while. Eli, you told me to slow down, but I don't see you doing anything. Okay. Well, now you're supposed to find the slope. So, where X is -2 is there. Where X is 0 is there. You got to rise and run. And rise over run. And then we got to do it. We got to do it there, and then we got to do it for the other one.
This one right here. This one. Okay.
And then y'all need to do it for the graph on the right.
Okay.
Y'all got to do it. Yeah.
Easier.
Y'all got quite a bit to do. And if you don't want to write in pen because you're afraid you'll get it wrong, maybe just write it somewhere. Yeah. Eli, you missed my entire lesson. So could somebody answer Eli? Eli said, so it doesn't matter at all which points I use. Could somebody explain the lesson to Eli? Does it matter? Is the slope going to be the same everywhere? So it does matter, doesn't it? Okay. Could this right here be an indicator of what point we're supposed to use? Could that be an indicator of what point we're supposed to use? It is, and Eli demonstrated that here and here.
Nice.
Yeah. You talking about the slope? You talking about the slope?
No, I'm asking about a point.
Okay, is it on the other graph?
No, it's on the graph we're getting at.
It's on this graph?
Yeah.
Okay, well, the ones that are labeled are really the only ones you need.
Yeah, but I think
All right, so the first one from -2 to 0, where x is -2, that's here. Where x is 0, that's here. Rise and run. So let's count. Notice there's a line missing, y'all. It's just too light. 1, 2, 3, 4, 5, 6, 7, 8. Left 2. So let's count again. 1, 2, 3, 4, 5, 6, 7, 8, and left 2. So here your rise is 8 over -2. Your slope is -4. Okay, from where x is 1 to where x is 4. Okay, here's where x is 1. Here's where x is 4. Gonna rise and run here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. Rise 9, run 3. When I simplify that, I get 3. Check this out. Not only are the slopes different, look at those signs. Tell me what about the picture? Why can I expect that possibly? What's going on in the picture? There's part of this graph that's decreasing. There's other parts of the graph that are doing what? So y'all, that's why you can get different signs for the slope under a quadratic, but you can't get it under an exponential. Okay? All right, last one, from where x is 1 to where x is 3. Okay, here's where x is 1, and here's where x is 3. So now we're cutting it short right there. So we're going to rise 1, 2, 3, 4, and we're going to run 2. So we're going to rise 4 and run 2. So notice all 3 of my slopes are different. Average rate of change. Yeah, I mean, you got 20 minutes. I need a bathroom pass. You need to be careful. Those are supposed to last you through an entire quarter.
Okay.
So that's, you got 7 more weeks.
Okay.
That's for everybody. Okay, let's do the last quadratic one. Let's go ahead and label our points. And again, y'all, at some point, y'all gonna need to step out here on your own. This is not, for this class, this is not new stuff. Okay, we need these ordered pairs here. Just for time's sake, I'm gonna label them for you, but this is the ordered pair 3, 0. This is the ordered pair 1, 12. This is the ordered pair 0, 15. This one's the ordered pair -1, 16. This is the ordered pair -2, 15. This is the ordered pair 1, 2, 3, -3, 12. And this is the ordered pair -5, 0. Do you have to label these points to rise and run? No, you don't. It seemed like this helped the last class, so that's the reason why I'm labeling the points. If you can find them in Rise and Run without labeling them, it's fine. All right, X is -5. That's right there. That's that point right there. X is -3 to this point right here. Rise and run. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and right 2. I need double checking here. So rise 12, run 2. Slope is 6 here. Okay? Right, from negative, x equals -1, that's here, to x equals 0, that's here. There's where x is -1, here's where x is 0. It's just a little jump. So we're going to go down 1, right 1. Down 1, right 1. The slope here is -1. Notice again, y'all, different slopes. And with quadratics, some parts are going to be decreasing, some will be increasing. Last one is from -1 to 1. So there's -1. What'd I do? You're saying Sheev. What'd I do?
I keep finding 11, but it keeps saying, when you said 12.
Okay, here's the reason why. If you pay close attention, the printer, look, the printer left out a line here, look.
Okay, sorry, I've been
Look.
that line.
Well, it should occur to you that that's a bigger jump than the rest of them. Do you see that?
Yeah, but that's
Okay.
my fault.
Well, that's why, no, it's not. It's what the printer does. There's a jump here too. Do you see how they left off that line down here?
Yes, ma'am.
Okay, so yeah, there's a line that the printer didn't capture. Okay? All right, last one, -1 to 1. Well, here's where x is -1, here's where x is 1. So down 1, 2, 3, 4, right 2. Down 4, right 2. Your slope here is -2. Right? Okay, I thought we were going to have time to do our little sheet today, and we don't. By the time I get it out to you, you guys aren't going to have a lot of time. So what I'm going to do is, I'm going to save it for tomorrow. Okay? So you guys are going to get a 10-minute break. We're going to behave during that 10-minute break. We're going to keep our hands to ourselves for the 10-minute break. We're going to try to refrain from cursing during that 10-minute break. We're going to try not to spit on anybody during the 10-minute break. Okay?